Round one, fight! Hadouken!
This is just a detailed list of all the functions that went into making this little animation. There's just the background. This is something I didn't use, but I'll use it as sort of a tutorial to show you how to make backgrounds transparent. This is one of the characters' poses, but you notice if I toggle that off, it kind of breaks the animation. So all these little poses of the character here, it looks like it's moving. This is not a GIF image. I'm just making certain images appear, and then as soon as they disappear, another one appears in its place, so it looks like the character is actually moving. To make it appear and disappear, I'm using domain or range restrictions, and you can do it on either or. I'm never having it move. I'm just having the range only valid for certain time values, so that's what makes it disappear. These images right here, where I had an old version of Ray's face, but without the background taken out, so I replaced those with versions where he has a transparent background, so it looks nicer. And again, tying the images to functions makes them either appear or disappear, or animate and move. So like this right here is an example of a function where I wrote in the x coordinate instead of writing its own function for these things to move and appear and disappear. You'll notice the fireball has two different functions. One controls the horizontal movement that goes into the x coordinate, and then the vertical movement, since it has no vertical movement, I use a constant function, right? Similar to like y equals negative 0.26, but this makes it appear and disappear. Appear at time 1 and disappear whenever the slider comes out to -2. That's when the fireball disappears, because that's when it collides at -2 with the Ray's face. And then all these little conditional restrictions on the domain and range create that illusion of motion, that illusion of animation. My time values here, I use variables instead of just keeping them as numbers, because I'm repeatedly using them in different functions, so that I know each little time value represents either when the fireball leaves his hands, or when he's finished his uppercut, or when he lands, or when the crate collides with Ray's head. And then this right here, just to give you an example of rotation, instead of rotation just tying it to the slider, I tied it to a function. So if you look at the A, and I'll actually slow this down. So I'm going to move the slider to be much slower so you can actually see this kind of like a play-by-play. So when I first play this thing, the crate comes in from the left and it follows the F9 function for its horizontal component. So it's moving, but it's also the F11. If you notice, see how it's getting bigger because it's like it's being tossed in the background. I have the F11 function, so it enlarges until it gets to the place where he's going to uppercut it. And then once he uppercuts it, I have the enlarging function to turn into just a constant function. And then if we go back a little bit, once he uppercuts it, I have it right here where it makes contact. I'm going to have it, which is determined by the F10, determines the Y component. In other words, its height, the height or the Y value. So right when it makes contact with Ryu's fist, I'm going to, instead of have it follow the function 0.1x squared plus 4, like a parabolic shape function, I'm going to have it follow a different parabolic path. So right here, when you see it moving, it's following that 4 minus 0.1x squared, but it only does that until time 6. Time 6 is when it collides with the head there, and then at time 6, I have it following a different function right here. It's just going to kind of go up and over off screen, so it's just going to go up right out of here. So, and then in addition to that, you'll notice that the crate doesn't always rotate. So the rotation is determined by this function here. I decided to have it not rotate as it comes into frame, but once it gets punched, it starts spinning. Then once it hits his head, it starts spinning a lot faster. And so I have a piecewise function, which you'll see on, that other video, but it has three different intervals. Right here, there's an interval, and then right here, there's an interval, and then right here there's an interval. So three different conditions. It's not spinning, then it's like, so that's what the 0 is. Then it's spinning by a factor of -0.5x, so it's spinning slow. Then I'll make it spin fast. And the negative makes it spin either clockwise or counterclockwise. But that's a detailed sort of rundown of how I made this.